this episode, I'm going to talk about hacking supervisory control and data acquisition, or SCADA devices. These are commonly thought of as devices in the field that run our electrical and oil and gas systems. They're also in factory floors and elsewhere. There haven't been too many examples of malware designed to attack SCADA systems. Okay, one example is kind of famous. It's Crash Override.
Crash Override. What was it? Mess with the best, die like the rest.
Okay, not the Angelina Jolie version of Crash Override.
Hide the planet! Hide the planet!
The version of Crash Override I'm talking about is also known as InDestroyer, and it's a malware framework specifically designed to attack electrical grids. It employs IEC 101, IEC 104, and IEC 61820, which are protocols specific to SCADA systems. So it wasn't some repurposed malware. No, this malware was designed to inflict damage on electrical grids. And it was used by the Russian government against Ukraine on December 17, 2016. So what happens when we start to control entire SCADA networks from the cloud? Couldn't a loose configuration lead to someone gaining control over thousands of devices in the field or on a factory floor? This is a story about how organizations moving their SCADA systems to the cloud need to secure them today, or they might find themselves attacked tomorrow. I'm Robert Vamosi. This is Error Code.
I am Chris Doman, CTO and co-founder of Cado Security. So Cado Security is a cloud forensics platform, but we use the cloud to investigate attacks across on-prem, in cloud, and kind of find out what attackers did.
What I was pitched was this idea that SCADA systems are now managed in the cloud. SCADA, those devices in the field, often designated to operate for, 10 to 20 years remotely, they're now connected in the cloud. So why would SCADA systems want to be in the cloud?
Yeah, I mean, it's a big trend. Some of those are similar to the wider cloud trends of you can shift your upfront CapEx costs. You have to go buy a big piece of hardware instead of rent it bit by bit. And also the SCADA software providers doing that as well. So rather than a one-off license, you're kind of renting it month by month. Long term, it can work out more expensive, but it's definitely kind of can cut some costs in the short term. Then also, I mean, you're looking too at things like solar farms, pretty distributed. It's quite hard to be having all that kind of connectivity otherwise. So cloud just connects things together. And it can potentially bring some security benefits too, compared to some of the more kind of legacy OT systems, but only if you do it correctly.
So let's go back a little bit. Traditionally, OT systems were not connected. They were not connected at all. So it has been this push to connect everything, everywhere. And how does that alter the fundamental security model for those devices then?
Yeah, I guess it's evolved over time. So before you go into the kind of almost air gap systems, people are expecting not to be able to connect to them anywhere, often quite proprietary protocols. And there's almost security through obscurity sometimes there. And then flashing back, 15 years, then people were connecting to the internet, but more kind of outbound for data monitoring. So you could see, you can monitor something like, is the power correct? All that kind of stuff. So you can remotely monitor these systems. And again, mostly just cut costs and also provide some more reliability. But now shifting into actually cloud hosted systems, which is kind of a new ball game where pretty much everything's sitting in the cloud, apart from some very small bits of equipment left on site.
I know in energy, oil, and gas, there are these models, one of which is Purdue, where you've got like different levels. At the top, you've got the network and business software. In the middle, you've got a DMZ that keeps the internet from actually interacting with the PLC devices, which are the lower levels. When you're shifting to a cloud model, though, I would think those models go out the window and something new has to be created.
Yeah, I mean, it's very different. And this is part of that kind of skills gap maybe between people that are designing those more classic networks and the cloud. In the cloud, it's not exactly a flat network, but if you misconfigure things, it is almost entirely flat across from one region across the world to the other. And then you get into complicated things like the way that access control works in the cloud. Very, very different to on-prem, where someone can authenticate somewhere, reuse it in another service. So that permissions and network boundary, they both can potentially change depending on how you implement it.
So Chris mentioned segmentation for discussion. Being a flat network, that's bad. So how tricky is it to segment the cloud? I mean, are we talking about a multi-tenant or a single tenant or containers? What goes into something like that?
I think it depends a lot on the particular provider of that software and whether you've done a classic kind of lift and shift where you've moved your network into the cloud. It doesn't have to be flat. It just potentially can be. And then the advice that came out this week from the UK government, I thought it covered it pretty well. It was talking about the difference between software providers that built their systems for the cloud to start with, and they are cloud first. And they design these things more in mind. Whereas if you're potentially shifting something that wasn't designed with the cloud, that can add some extra risks.
Chris mentioned lift and shift, and I haven't heard that phrase in a while. What it brings to mind is that these companies are not really thinking about the cloud as being different. They're just simply taking their network architecture and moving it up. And it doesn't necessarily work that way.
Yeah, I mean, and to be fair to them, maybe it wasn't designed for that in the first place. They may not even be marketing it to be used in the cloud necessarily, depending on provider. But CEO of a large company gets an airplane, sees clouds everything, and mandates that shift. So there's a whole different potential world of models here, and all the different type of protocols that exist in the very complicated SCADA world as well. Kind of.
The reason I'm talking with Chris is that in the UK, the National Cybersecurity Centre has issued new guidance around SCADA in the cloud. That's pretty specific. I know in the United States, there are all these different initiatives. And for example, NIST 800-207, which defines zero trust architecture, it defines it broadly, but not specifically. So what the UK has done is it's rolled out its own guidance for this one specific area, SCADA in the cloud. How prescriptive is it? And how prescriptive should it be?
I thought it's pretty British in that it's not that prescriptive. If you read through it, there's quite a lot of back and forth between different pros and cons. There's some context there too. This is partly off the back of Vault Typhoon, which I saw you covered on a previous episode as well. So it's good. It gives some examples. It just discusses pros and cons. And again, in a very British way, says we're not recommending something, whilst at the same time recommending it as well.
So something like this is just a great discussion point. It doesn't ultimately move the needle, or does it?
I think they're trying to put out some things yet to be discussed amongst the different teams, and then raising key risks. So risks around, do your personnel really understand the cloud? Does your software provider really understand the cloud? And I think they're trying to move that conversation on to internally instead.
Chris mentioned different industries and different software. This is pretty focused. It's focused on the SCADA system, which is out in the power grid. But there are other uses for SCADA.
Yeah, I guess you got SCADA in terms of those actual control systems. Then wider there, you have industrial control systems and also operational technology. And SCADA is kind of particularly overlapping. They're particularly key for energy, but also potentially other things like there was an attack against a water system in the US last year. That could potentially come under SCADA as well, or SCADA, depending on how you pronounce it.
So these guidelines that they're out there, they're focused on a part of ICS.
Yeah, I mean, in some ways, this is actually a supplementary report to a wider cloud security piece they issued last year, and they reference that a lot. But this is, I think, very much based on, CISA's guidance around SCADA as well. And again, the Vault Typhoon kind of bringing that back up. So I think they basically stuck some extra bits on there with a few of their experts and then tuned in on one very particular threat that's, I guess, has raised that profile the last year.
Chris mentioned an earlier report. It was much broader.
Yeah, so the NTC published some guidance around how to secure your cloud infrastructure. And that goes into all the things you've seen if you've done cloud security before. So things like minimum access, making sure you set up that access correctly, all the common misconfigurations. And that's the kind of fun thing about cloud plus SCADA is that you're combining two potential pitfalls there at the same time. So there's extra things to watch out for.
So Chris mentioned cloud-first companies getting into this space. And I would think that something that's critical infrastructure would be very scary for anyone to get into. I might want to go in with somebody who's been in that space for a while. I mean, there are new players in the market. Can they actually do a decent job of securing this stuff?
I mean, the core cloud providers, so AWS, Azure, GCP, all publish some guidance around the key risks. They don't go into that much detail, with the exception of Microsoft that has published a bit more around there. I don't personally know the software players, though, in terms of SCADA systems that well beyond, the big guys. But I do know that in general, there has been more movement with some newer players kind of entering that more cloud-first market.
So let's talk about the cloud. The security model there is very different. You can have security brokers, or you could have it be native. Chris can explain the difference.
Depends on the security brokers. We talk about like privileged access management and those kind of things that author, Yeah. So again, if you look at the UK's guidance, they talk about this a bit in terms of you might have there be like a CyberArk, for example, which can control some of that authentication across multiple different planes. So maybe on premise, you're using the same people to authenticate to cloud. Maybe you're doing it differently. And then kind of working out exactly how you do that is extremely complicated. I'm yet to see a company that's actually successfully rolled out a fully central authentication mechanism that is a large company, and particularly when you're adding in complicated on-premise environments. At the same time, it's better to try than the alternative, which is that maybe you're on your on-premise environment, you have someone just walks up to the system, logs in, in front of it, and then in the cloud, they then use something entirely different. At least there's a movement to have these kind of access brokers instead.
So let's drill down on accessing the cloud. Is it different than an on-prem system? And are there some major differences that should be called out?
I mean, one of the major differences with accessing and authenticating in the cloud is that so much of it is fully automated. So rather than having the concept of a user or a person, in general, that's now moved to the concept of a role or a policy or an actual resource itself. So the way that you prove you have access isn't that you are Chris. Instead, it's that you are this particular machine. And the good thing is if you do that correctly, that is more secure because you can't go and steal a password. The bad thing is that you have to know how to set that up. And again, if it wasn't designed in the first place, then that can go kind of wrong.
So from Chris's experience with Cado, has he seen this type of misconfiguration leading to problems?
So we see all the time when someone's misconfiguring something like that, and there's been some kind of incident. Most of the time in the cloud, it's pretty low risk. So it's something like someone left open a service and then someone's installing like crypto mining. Sometimes it's ransomware, which gets a bit worse and deletes that data. And occasionally we do see that move on to the on-prem world as well. And there can be some overlaps there.
I guess what I'm looking for is, does Chris have a good story?
Yeah, sure. So something we've seen on multiple customers who have left open their Docker APIs. So Docker is a really nice way of spinning up and spinning down compute resources. So systems are really, really fast. But depending on how you configure it, you might leave that open. And the very common thing an attacker will do is they'll start up a bunch of their own systems. They might try to take data, although that can be a bit trickier. But often they'll just simply be stealing your power to mine Bitcoin and things like that.
So potentially someone could find a way to authenticate themselves into a SCADA cloud. Yeah. How does that play out? What does that look like in terms of a potential attack? Like, could they hold it for ransom? Or could they mine the data?
I guess stepping through what the attack looks like, it could be anything connected in that cloud environment potentially. So it might be a low priority system, maybe just a normal web server. And if there's a connection there, which doesn't have to be over the network, it could be through cloud credentials, they can then access other systems. What actually goes on in terms of the real physical impact depends a lot on what that system is and how that's connected. But if you're talking about the particularly scary cases, and this is not a cloud one, if you look back to Russia disabling 2 years in a row on Christmas Eve, Ukrainian power plants and power systems. In that case, they flipped back to manual operation, which was actually good. They still had quite an old school system. They could take that power back. But there are plenty of very scary things. I think I said before, too, there was a water system in the US that was impacted as well. Not many details came out on that. And that was due to potential vulnerability in some of that software.
As I mentioned on previous podcasts, the Oldsmar attack, the FBI is leaning toward it was an insider attack. The important point here is the idea of resiliency. If we're talking about a manual takeover of a system in Ukraine in order to keep the power going in the middle of the worst time of year, crash override, how would that work in a cloud system? Because basically everything's automated and so forth. I mean, are there manual controls?
I think it depends a lot if you have a hybrid environment where you may be using your cloud as a backup rather than the primary there, or the inverse, so you may have redundant instead. So, I mean, that is also part of the guidance that I've seen too, to think about these situations. It doesn't have to just be an attack either. I mean, it can be something as simple as cloud providers do go down sometimes, so you can't rely on them to always be up there. Even AWS and Google, they do have downtime.
And how general is the resiliency with the cloud? We're speaking beyond SCADA systems here. What has Chris seen when AWS goes dark or Google?
I mean, it's interesting that everything is super resilient. So there'll be backups of backups of backups. But at the same time, there's the large outage in AWS last year where it turned out some of those systems were interconnected. So when one went down, it took out some of the connected backups as well, essentially. So, I mean, generally, they're pretty reliable. I definitely trust it over an on-prem data center, but nothing can be guaranteed 100% of the time.
So the report is calling for overlapping resiliency. Does that work?
They're discussing the pros and the cons between of a hybrid approach versus pure cloud or pure on-prem. So it's one of the options. But Again, I guess it depends on the implementation anyway.
Again, this sounds chiefly British, where they're just recommending what would be a great idea. Yeah, but it's not prescriptive and not what you must do in order to secure your system.
Yeah, Caesar and US may be a bit more direct.
Again, there's some criticism around any sort of guidance, particularly around ICS. How prescriptive can it be if it's written so broadly? So you should probably be able to get some guidance that's specific to those industries.
Yeah, definitely. I mean, some of the sector-specific guidance is pretty good in my opinion. HIPAA in healthcare actually says you have to prepare for incidents and that you have to investigate and all these kind of things too. So some of them are, because it's regulation, they really do drive up people's kind of baseline security. But again, it's so hard to keep all that up to date. And then there's a difference between someone saying they've implemented it versus actually implementing it and all those classic kind of issues too.
I'm actually interested in how much forensic data remains after an attack. It seems like with the cloud, it's ephemeral. And, well, anyway, containers, they spin up and they spin down. And how does Chris go back and discover what really happened?
Yeah, I mean, that's part of the fun problem because those containers can disappear quite quickly. So one thing is you can automatically capture them. So if you set that up so you can capture that data before it gets deleted, that's great. That's not always possible. The whole idea of forensics is that if you have that data, you can parse everything and kind of go backwards in time. So if you do have some data, you can generally get it there too. And another nice thing in the cloud is that data is often in multiple places. So you might have it in just some logs on the cloud provider side, but it may well, those same logs may be copied onto the actual raw system itself as well. The problem is that by default, those logs aren't actually enabled. So you have to go through and enable those logs, or otherwise you have to go and find some other way of getting them after the fact.
So if these aren't enabled in the beginning, then Chris's job is much, much harder, I would think.
It's much harder, but it's also the value we often add because we can still get that data via other means sometimes. And that's some of the creativity there. But yeah, definitely, if you're in the cloud, enabling the key logging is one of the first things to do.
I'm also wondering, does any of the forensics in the cloud map to on-prem forensics? Or is it an entirely new thing?
Some is the same. If you're looking at operating systems and disks, then you'll still be looking at Linux web server, still be looking at Windows domain controller. But some things are very different, particularly with those cloud provider logs. That is very, very different. By default on-prem, you generally have those logs because they're just sitting there on the disk. Whereas in the cloud, you have to enable them, or they might be stored in some random wacky place that Google decided to put them.
So does Chris have experience with on-prem forensics?
Yep. So personally, my history was I was doing DFIR, mostly on-prem for a very long time. So it's interesting translating that into more the cloud security world.
And I wonder, does it take longer in the cloud or less time?
Definitely acquiring the data on-prem can take a lot longer. If you're going for a full disk image, because you might have a terabyte, you have to sit there, copy out the disk, etc. Although a lot of the way that things are moved is to more triage capture on-prem because it's so slow. So instead you're capturing just a small subset or using something like a CrowdStrike or a SentinelOne instead. So it depends on basically how bad the breach is. But in general, the cloud is fast to respond if you have got access to that data.
Okay, so incident response in the cloud is much faster, in Chris's opinion.
Yeah, and it generally has to be because some of those kind of flat network issues we discussed as well, where potentially a breach can spread quite quickly. So yeah, if you're set up correctly, then in general, responding to breaches in the cloud is faster than on-prem, although the skill set isn't necessarily there yet.
So where is the gap? Is it in behalf of the analysis after the fact, or is it in the people setting up the cloud environment to begin with?
Primarily in terms of the forensic investigators, as well, I was thinking, because they may not know. There's a lot of training going on, and SANS doing a really good job here. But a lot of people doing DFIR and forensics aren't fully into the cloud yet because it is a whole new scenario to retrain on.
And really, cloud should be a known entity. We've had it for a while.
Yeah, it's interesting. The number of breaches seem to be increasing. I guess it's because 20% growth year by year and things moving that way. And also the types of systems of the cloud are changing. I mean, not just OT, but also people are moving their domain controllers and core architecture in the cloud now, whereas I think 10 years ago that was happening less.
This also affects hybrid cloud, where you've got on-prem and cloud sharing the data.
Yeah, definitely. And you can see things like someone's laptop gets compromised and they move to the cloud, or the company may be storing data in both places. And then if either one gets popped, that's bad news.
So I'm wondering, as an attack vector, is Chris seeing more of an uptick in the cloud SCADA systems being attacked?
What we're seeing is that the cloud providers are improving their secure defaults. So even though the number of attacks might be increased, the number of silly attacks that are successful has decreased. So just for example, if you go and upload data to a cloud storage, so Amazon S3 bucket, something like that, by default now it's quite hard to make that public. They'll warn you a ton of times before you do that. Whereas rolling back 5 years, that was pretty easy. And people were sticking like credit card data public on the internet without realizing, which is crazy. That happened a couple of times. Whereas now that's much harder to do. But the number of people trying to attack it is probably about the same.
So if he's not seeing an increase, then this is an opportunity for security to actually catch up.
Yeah, ideally. I mean, the fact that those cloud providers control the physics means they can help there. But some things are switching to the cloud, though. So cloud ransomware is definitely more than the last year. People are going encrypting people's data in the cloud, not just systems, but also in their storage accounts, those kind of things. And I definitely wasn't seeing that a couple of years ago.
What Chris is saying is that the forensic examination analysis has to come up to speed, and there needs to be more training in this area. Unfortunately, the criminals will be doing that as well. They're going to be trying to figure out all the cloud configuration stuff that they can access, such as an S3 bucket.
Yeah, and definitely you're seeing that move there as well. I mean, for one thing, emails is really interesting because the emails used to be stored mostly on servers. Obviously, now they're stored in cloud servers and Microsoft Exchange, those kind of things. And there have been lots of reports of nation states now attacking and starting with those hosted email providers like Microsoft instead, because that's where the data is. The emails have all the interesting information.
So it seems like we're circling around the whole authentication access issue. It seems like Chris knows that systems aren't well set up.
Yeah, in a sense, it's kind of a more boring attack vector than go and find some really cool exploits, pivoting around network. But again, that's how the data can be accessed now. So in the case of those exchange hacks, between credential stuffing, just trying lots of accounts, seeing who they get into. Not a very exciting attack, but they had to do some smart stuff to like hide their IP addresses and things, but quite a successful one based on the public reports.
And criminals tend to go for the lowest hanging fruit.
Yeah, exactly. And the cloud can potentially bring that a bit closer to the attackers as well.
I think with SCADA, we've had open systems for quite a long time. It was like, well, why would you want to connect a sensor to something in the field? Now that sensor in the field actually has compute power and actually has a robust system on it. And they're far more interesting than the dumb sensors that were out there before. They've become a target. I guess some of the players in the field are producing these, and they're not really thinking about the threat landscape just yet. They're seeing the attacks, maybe. Maybe they're not.
Yeah, it definitely depends a lot on those providers, how sophisticated they are. I know that Siemens do a ton of research with the community where they actually will go and investigate any malware, and they team up with the research to look at anything that attacks them, which is pretty cool. I don't know if everyone has those kind of resources though. And yeah, it does depend as well, as you said, a lot on how those networks are connected together. If you've got something sitting on a network from the 80s, and that is still the case in some environments, with something in the cloud as well, that's a weird mismatch.
I haven't looked at Shodan lately, but Shodan wouldn't necessarily tell me the information about the system, or would it?
I guess it depends. I mean, it will scan systems, and you definitely do find open connected SCADA systems. A common thing that you'll find in Shodan is that there might be a Windows RDP session, so you can actually see the screen, the login box, and there's lots of famous screenshots of someone saying, "Oh, I found this interesting SCADA system." They can tell what it is because the wallpaper in the background says, "Warning, this is something. Please don't connect." And that also kind of gives the game away.
Actually, I think screenshots look a lot scarier than they really are.
Yeah, it may well have been an intentional design choice to make that particular system internet accessible for reasons. I mean, generally that's not a great idea, but that there may be a business case there to do that.
Returning back to the Ukraine situation, crash override, also known as in-destroyer, nation-state stuff. Are they interested in the cloud? Or is this still the criminals, and they're just usually looking for whatever they can get into?
Yeah, I guess they have to go where the data is, particularly if it's espionage or some kind of disruption. So if you go through the reports around some of the stuff going around the US elections, with some very famous interference there's actually quite a large cloud angle to that, where some of the voting systems, they had some backup stored in the cloud, and then buried in one of those FBI indictments is saying they accessed these snapshots of Amazon EC2 systems in the cloud, and that didn't really get much coverage, just because thankfully they didn't do anything that bad with it in the scheme of things. There are wider attacks there instead. But definitely wherever the data is, espionage will follow, and potentially disruption too.
So they had access to it, but maybe they didn't have use for it.
Yeah, I think so. I mean, maybe that's a good thing. The attackers take a bit longer to understand that data as well. From what I remember from that particular document too, it was quite close to the elections. They didn't have enough time to kind of operationalize that data as well. So that might have helped as well.
I'd like to thank Chris Doman for coming on and talking about SCADA systems in the cloud and how they need to be secure because, well, they're becoming targets. Hey, if you're enjoying Error Code, tell a friend. I'm sure there are other people out there who like narrative information security podcasts. And I'd really like to hear from you. Join us on Discord. Search for Error Code Podcast to join the server, or go to errorcodepodcast.com to get more details. And tell me what you like, and even what you don't. I have more conversations coming up, including incident response in OT and microsegmentation with IoT and OT devices. Subscribe today. I don't want you to miss out.